Hey everyone, I know we've all been there. You build your first shiny app. Everyone in your organization goes, wow. You become ambitious and try to create a lot of shiny apps that are life changing for your team. And then it happens. The infamous disconnected from the server. So you learn about all these new ways you can make sure that that never happens. But it just takes too much of your time and effort. What am I doing wrong? There has to be a better way, right? Maybe. Let's find out how to do a comprehensive audit of Shiny app through CICD and move towards production readiness. That's not going to happen anymore. And I'm delighted to introduce our next speaker, whose reputation precedes him, David Granjon from Novartis. Welcome, David.
Hi, hi everyone. Really glad to be here. Yeah. Is the sound okay? Yeah.
Yeah, we can hear you.
Okay. Perfect. Yeah. Yeah, I'm very delighted to be part of this amazing event. Thanks for organizing this and also for the very cool introduction about CICD and Shiny apps. I'm gonna share my screen. And also the link to the slides before I forget. Okay, let's go. So yeah, briefly about me, I'm David Granjon. I'm working at Novartis. I'm senior expert data scientist, and my role is basically to help associates to develop production-ready Shiny apps. So today, and you probably know me because of my work around interfaces, bootstrap design, how to improve Shiny apps interfaces. But today, this is something really different I will present. And it's about a new package called Shiny Validator. I've been working on the last 6 months just to ease the audit process for Shiny app quality through CICD. So Shiny apps may look amazing, and today Shiny is about 10 years old, so that's quite amazing. And there are many tools to make your application shining. So if you are not aware, I wrote a book in the past 3 years, which basically is called Outstanding User Interfaces with Shiny. And in that book, I introduced like a lot of tips and tricks, methods just to improve the design of your apps. But the point is, despite all these nice tools, then there are too many explained syndrome. The well-known, it worked for me, but not for you. The famous, it was fine yesterday, but unfortunately today my application is not working, and many other diseases. And the thing is, your app may be as beautiful as you want, it is just useless if it doesn't start or if it doesn't run properly. So there are a few questions about why my application is not starting, not running. And I think the answer is that at the very beginning, most applications are just prototypes, and they are not really think as like production-ready applications in the beginning. So there is like no planning for the development, poor quality management, no test, and then yeah, this just must stop. So some words about software validation. What do we mean by validation when we build like an application that could be Shiny app, but that could also be a React application or something written in PHP with database or whatever. So we have to, to work with business users and just to make sure that what we develop is conform to some requirements. So they have some requirements. They want, for instance, to save data in the database. They want like to have a specific download button to export a report. So you have to make sure your application deliver everything at the end. So this is what you have to do for validation. Just make sure you fulfill the initial requirements. And this is tricky. This is really tricky. So for Shiny apps, it means you have the first thing, reliability. Is the application doing what it's supposed to do? That's the first question. If you click on the download button, do you download a table, for instance? Do you download results? If it's not the case, then the application is not reliable. Is it stable? How often does it crash? For instance, if you cannot click twice in the app without having to restart the server, then it means the application has a problem. And then the question of performance availability. Is the application fast enough to handle multiple conference users? So you can have an application, but it works well with one user. And then when we have like 10 different users, it becomes complex because it's just laggy, they have poor experience. And yeah, if they have poor experience, there are high chances they don't use the application anymore, they complain, and then everyone gets frustrated. And this is a situation you don't want to experience. And in practice, a few apps meet all these requirements. And the question is, how do we transition from prototype to production-ready tools? So here I show this book, which is called Engineering Production-Grade Shiny Apps, which was written by the Vanguard team. And in this book, what I really like, it tells a story of how you basically develop a Shiny app from the start until the deployment on the server. So it goes really just beyond the technical stuff. You just have everything like from the beginning, how you should design the mindset you should get. And of course, in the middle, you also have a lot of things about testing, about unit test, about load test, about profiling. So what I'm going to present today is tightly linked to what you can find in this book. So that's the reason why I recommend to read it. So the first thing today, I think it's quite clear that you have to package your Shiny app at some point. So I show here the Golem package, but you could actually use whatever package you want. Because with a package, it's just easier. You can check the code, you can link the code, you can document, you have easy access to documentation, either for developers, but also for end users. You have easy access to testing, so it's just easier in the end. And it doesn't take a lot of time with the tools we have right now. Use these dev tools that literally take a few seconds to create a new package. So why not taking that opportunity? Second thing is you need to manage dependencies. So it's good if you have like your application, your package, but then if you work in a team, you may not have the same package versions on different computers. You work with different operating systems. Your colleague is working with Linux, you are working with Mac, you have another colleague on Windows, and then at the end, you're the only one able to run the app. And this doesn't make sense. So now with tools like RF, you can manage dependencies, you can capture package versions and share the same version between every people in the team, and then you're sure everyone can start with the application. Then the next step is to test the code. So as long as you add new features, then you want to test them to test whether they worked correctly. So we have basic unit tests, just using test.that package, where you test the business logic. And this is where I would recommend just, when you develop a Shiny app, and this is also written in the engineering book, and recommended a bit everywhere, but you really have to write your functions just without reactivity, and then put the less thing possible inside reactivity, just to decrease the complexity of debugging things. So you have other tools like for server testing, where you can test how Shiny modules work together, testing reactivity, and finally UI testing, where you can test, like how your components print in the web browser. You can take snapshots if you have several outputs in your application. And then you have the optimization part, where you still have to think about performances, because in the end, if you have multiple users, then you want the app to react quickly. So are there bottlenecks in the application? So you can identify them with several tools like load testing, with Shiny load tests, profiling with Profis, and investigate reactivity problems with React log. But the thing is, there are like many different tools. I already mentioned Golem, I mentioned TestDat, Shiny load test, Profis, and many others. And the question is how to use them properly, because if you are not familiar with those tools, you would have to go through all the documentation. And the question is there a way to automate all of this? Because we don't necessarily have time to run absolutely all tests locally. And you also need to consider the setup for Shiny load tests, for instance. That doesn't just work out of the box. You need some system libraries. So everything it's not easy, right? So this is where I introduced CICD. So CICD is continuous integration. So CI is continuous integration, where you automatically check new features. And CD stands for continuous deployment, where you automatically deploy the content. So if I can give you an example, if you have a project, a Shiny project, and inside that project you get 20 different applications to deploy, you're not going to click 20 times on the Astio Connect publish button. What you want to do is just to have one script that deploys everything each time you commit to GitHub, to GitLab, to wherever platform. And this is where continuous deployment is useful. You need a remote environment like GitHub Actions, GitLab CI/CD. What are the benefits? As I said, it's an automated process. It's more reproducible. You have more operating systems. You can have more R flavors if you want. So you have a large spectrum where you can test your applications. It's time saver. But the thing is, it's not easy, right? Especially if you don't have any experience, you have to select the DevOps platform. Sometimes you don't have choice. If your company is using GitLab and then you know everything about GitHub, then you need really to adapt your knowledge. You need to know a bit version control. Sometimes you have to build a custom GitLab runner. That's the place where the job will be running, which is not easy. You have to write the CI/CD instructions. It's also not easy. So in the end, the question is, can't we make things easier, right? And this is where I introduce Shiny Validator. So the purpose of Shiny Validator is to ease Shiny app validation. So it provides plug-and-play CI/CD templates, and then it provides some workflow where you first lint the code, you check the package, then you perform some crash tests to test whether the application starts, and also whether it stays alive after some manipulation, just to make sure it's reliable enough. And also some output checks. If you have some plots, some HTML widgets, you would like to know, if there are some differences between commits so that you don't break accidentally visualizations. And some performance measurements like load test, profiling, reactivity checkup. So you don't need to install everything on your end, just need to run the code, and then everything generates a nice HTML report which can be shared with everyone. So there are a few requirements. You need a package, and it was built with Golem in mind at the moment. So maybe later there'll be basic support for any R package. But I had to start somewhere, and it was quite challenging just to get everything working properly. So you have to control dependencies with RF. I think here it's quite fair enough. It's not complex, and then it's really better to use RM but not using it. It requires to use Git and also have a remote repository. And obviously, Shiny Validator doesn't write unit tests for you, so you have to write those unit tests. To set up, then you just have to run that command. You can find it in Novartis/Shiny Validator, and then you run the validator command. You select the platform you want, and then So before going into the live demonstration, just to show you how it works under the hood, you have a main function which is called audit app. And then this function basically consider many different things. So as you can see on the right side, you can have different Shiny Apps projects. On the left, this is a DMC that we use in pharma. So DMC stands for Data Monitoring Committee, and then you have high expectation usually because you inspect safety and efficacy of treatments in the Shiny app, and then it must be very reliable. And on the other hand, you may have proof of concept application, and then for those different apps, you don't have the same expectations. So on the left part, for the production-ready app, you will have all possible tests, the linting, just to make sure the code is consistent between collaborators, checking, crash test, output validation, load test, code profile, reactivity analysis, like whatever you want, and then you generate the report. And on the right side, you don't necessarily need all those kind of tests. You don't necessarily need output validation or whatever. So you would only have checking and also the crash test. And then the report is deployed on GitHub Action, GitHub page, on GitLab page, but it can also be shared on any web server, on RStudio Connect. So yeah, wherever you want. And this function is quite flexible, so you have multiple parameters where you can select if you want to activate output validation, if you want to show the code coverage, if you want to do a load testing, if you want to provide the code. So it's very flexible. So live demonstration is probably better than me talking forever, so I'm going to switch to the live demonstration right now. Okay. So on the right side, I'll be working on the right side, and on the left side, I have some instructions to go quicker. So on the right side, this is a Golem package which I created. It's called Shiny Validator Epsilon. Yeah, I'm gonna enlarge a bit the code because it's quite small. And it's a Golem package, so you have like the basic structure. It took me like 1 second to create it with the command. Have the R folder, have the man folder, the description. So what I need for Shiny Validator is first, I need to set up RF just to manage dependencies. So what I'm doing now is creating an environment variable to make sure I install the Rev library outside the project. I don't want to install RF packages inside because when I'm going to do the check, the DevTools check, it's going to take forever because I'm going to copy all package file in the 10 folder and I just don't want that. So reason why I'm creating this variable, and I also restart the session so that the variable is considered. And now I can initialize RF. Okay. So now I just need to restart the session again, but this is something RM is already doing. I don't have any package, as I said, in the RAM folder. They are at the location specified here. And the next thing is I want to install the Shiny Validator. I already did it before, so I'm not going to do it again. But I'm going to show you just to load the validator here. And there are some checks. Yeah, it says that okay. So I'm going to recreate a new project because I think this one, I don't know what happened again. Okay, let's call it like this. All right, and I just restart what I did quickly before, creating the environment variable, initializing the rel repository. So this is what should have happened before. I don't know what happened. There was probably something staying on my computer. Okay, so now I have the rel.lock, and this is why I get the previous error, because it was not finding the rel.lock. So yeah, let's try again here. So I just need to say yes. Okay. I'm really sorry, I don't know what's going on with the computer. Okay, so I'm gonna set the Git repository, because this is not a Git repository yet. So I can select yes, I will commit the files. Okay, and then I just restart RStudio. I'm going to use SSH protocol. Then I just need to set up some stuff so that I don't get any errors, or warnings in the RCMD check. So set up the license. I also need some tests. Okay. I need to connect this thing to GitHub also. Okay. So this essentially created, the GitHub repository. I'm using useless, so it's really, really straightforward. And then I need I call the Shiny validator, use validator. I specify GitHub because I'm using GitHub. Okay. Perfect. Okay, so I'm really sorry I have to stop the demonstration because there's something wrong in the computer. So yeah, you can find the whole documentation in the website here. Basically, you just go through the Novartis website, and then you have all explanations to set this up, all explanations about the different steps, so you can fine-tune them. So I'm gonna switch to something that already exists. So that's a repository with Shiny validator setup. So what you will notice is for GitHub, you have a GitHub workflow, and then with several things inside. So what I said, it's running on different systems, like you have Ubuntu latest, and then several things. And then you have the steps here. So the first thing is set up R, then you have dependencies, you set up RM, where you restore packages you get locally, and then some extra stuff to install, like Shiny Canon for the load test, the Chrome browser to use Shiny test as a headless browser. And then you run the Shiny validator, the audit application function, and then you deploy to GitHub page. So imagine you have the same thing if you use GitLab, except that it's tailored for GitLab. So now I just show you, I was on the Shiny Validator dummy project. So this is what you should see in GitHub. So you have an actions tab and you can preview the GitHub action builds. And then what you will see is the three different jobs for the three different systems specified in the YAML file, and then all the different steps which you can review. So in my case, everything was fine. So you can see different steps here, like the crash test, the load test, and then you have some profiling, React log, and then the coverage and the report generation. And at the end, everything is sent to GitHub page. And this is a report you get. So this is an HTML report where you have the DevTools check, which is a bit better than the one you can see in the console. What you want to see actually is everything in green. Here you get the crash test with some snapshot of the application. So it's basically simple app with some checkboxes and a table. And on the right side, you have something called monkey test. This is a nice thing. So I wrote a Vignet on the Shiny Test 2 package if you are interested to know what it means. But basically, you trigger a lot of different interactions in your app randomly, and then you try to make the application crash. So this is what I can show you here. If I click on enter, then this is what you see here is the monkey test. So I try to click everywhere at the same time, and then what I want to see is whether my application crashed. So this is Bootstrap for dashboard. And if at the end of the crash test your application is still alive, then it's quite good indication that it's stable enough. You can remove like the random part of the monkey test by using like specific instructions if you want to really click on a specific button or whatever. So this is definitely possible. Then you have the coverage report. So because I don't have unit tests, you don't see anything in this report. I have 0%. The load test report. So this summer, you get the output you get in the Shiny load test package. So everything is taken here, and this is just the load test report. So you can see a lot of blue in the app, a lot of like home page in red, which means the application is not optimized at all. And what happens is basically most of users are just waiting for other people to finish their session, which means there are lags and some optimization space to do. Here is a reactivity log, which is fairly simple because you only have one variable, one input. And finally, you have the code profiling. So the load test gives you a good indication whether your app will support multiple users, but it doesn't tell you if your what part of your application is slow. So in that thing here, I just run the prof this, and then you get the report in the Shiny Validator global report, and then you can inspect which step is taking a lot of time. So here I use sys.sleep, which is not captured by Provis. It was just to simulate for the load test. But in real situations where you have real computation, then obviously you would see a lot of time here. Okay, so I'm gonna end the presentation here. Yeah, so sorry about technical issues. Yeah, and thanks again for the opportunity.
That was a terrific presentation, David. I particularly like the monkey test. I call it John test. So John is the user who comes back to you and says, "I did that in your Shiny app, that didn't work. I did this in your app, it didn't work." So It's nice to simulate that before you ship it to John. I really love that. We have
I
a
just
few.
wanted to thank Barrett Lucky from our studio because we were working a bit together, with Shiny Test 2 developed in parallel, and all my team in Novartis just to support that work and encourage me to go in that direction.
We'll just have one quick question before we wrap up. Uh, Not coming from a software development background can and developing Shiny apps can be sometimes intimidating to get started with tech topics. So, for anyone who does not know how to get started with tests, what would you recommend them?
I think they should go through like the documentation of all packages, like Shiny Test 2, for instance. It's very well, like you have a lot of vignettes here, the getting started guide. It not only explain, the technical part, but also the rationale behind what you should do it and how you should do it and what you should be careful. So if I take an example about snapshots, right? They'll be different because you have different web browsers, you have different operating systems, so you have to be very careful when you design tests. So it's complex because there are a lot of technical details. So that's something you learn on the go. And a package like Shiny Validator is making things easier. But as you see in the demonstration, sometimes it can go completely wrong, even when you know CICD. So yeah, I think in the end, it doesn't write tests for you, right? You have to write them anyway.
Yeah. Okay. If you had to pick your most important arrow from the quiver of all the things you've mentioned, what would it be? Like you would never put a Shiny app in production without doing this one thing.
I would do like at least a crash test, like a package check, checking the like the DevTools stack, the basic thing, the crash test to test whether your app starts, the monkey test whether it stays alive for some time, and then you're not obliged to do the load test, right? Not at the beginning. But yeah, at least the crash test because you don't want to deploy something that doesn't work. This is the main problem. That happens quite often, on Friday afternoon. You write the code, you deploy the version, you push on you connect, and then it just doesn't work because you didn't try, you didn't have time, and that's too bad, right? And with tools like Shiny Validator, in like a check takes the first time you run it, it takes about 10 to 15 minutes just to install all packages in the CICD stuff. And after that, you have the cache, so it takes about 5 minutes. So in 5 minutes, you get a good idea whether your app is in a good shape or whether it's not.
Awesome. So you guys heard it here first. Crash test and monkey test is here to stay. Let's do that. Okay. Thanks a lot, David, for a terrific presentation. We hope that you'll be here for the next year conference as well. Thank you.
Thank you very much. Yeah, bye bye.